Listen, there's not enough hours in the day.
Everyone's sharing embarrassment.
So I wouldn't even know where to begin. I'll say this: if there's a worse feeling than embarrassment, I don't know what it is. Like, I don't think so. I think there's something, because like disappointment, at least to me, like disappointment is tied to like a real thing. Like you're disappointed because something bad has happened. That at least gives that emotion meaning. But embarrassment is just this empty thing. It doesn't accomplish anything. It's just the act of feeling less than for no good reason. It's an awful thing. Anyway, when I eventually get fired for teaching for telling embarrassing personal stories, which is going to happen, I'm going to need some kind of change of career. So, oh, I forgot to print the right version. Oh, the right version had your names in them. Well, this is less exciting.
What is this?
Jade, I can't work with.
Yeah, this is, oh, these are you. I'm very disappointed. Well, that's okay. So imagine that, this says Evan, but we don't mean Evan. Let's say that Dawson's building a house, an addition to his house, right? So he's got a house and he needs a contractor. He's got to hire somebody to put an addition on his house. All right, and Jade isn't here, so let's see. Well, I know who's... Turn that off, for God's sake. Seriously, shut it down. Okay. So Daisy is a contractor at this stage in her life, and she quotes him a price of 150 grand. He's doing a serious addition. Putting a big old dish on the house. Take this off, please. Thank you. So I am desperate for work, and I undercut Daisy. All right. Yeah. So here's the deal. Daisy wants 150 grand, and she says she's going to do the job in 25 days. 25 days to get this addition built. She's coming in with the whole crew. Big job. That's ambitious. But she's going to do it. And 150 grand, what's that a day, I wonder? How would I figure that out? Just out of curiosity. It's not even part of the question, but I'm just curious. So 25 days. So what do I do with those two numbers? Yeah, very good. So I'd do 150,000 divided by 25. So Daisy's going to get paid 6 grand a day to do this job. Now, she's got to, listen, she's got to pay for supplies. She's got to pay her crew.
That's still 6 grand a day.
She's got to pay like her enforcement who go out and break people's kneecaps if they don't pay. Like all those things, they're important. She's got to pay for them. That's actually my other side job. It doesn't mention that on this. Yeah, my 2 jobs now are I do low wage renovations and I rough people up if they don't pay Daisy in her crew. So Daisy's offered this job, and I am real desperate for work. The teaching thing didn't work out for me. And so I go, Dawson, you know what? I'll do it a little bit cheaper. I'm going to do it for a penny on the first day. First day, you got to pay me a penny, 1 cent. To build your addition. Day 1, you're paying me a penny. But it's going to grow. Day 2, I'm going to make you double it. You're going to have to pay me 2 pennies. All right, let's go. I want you to tell me how much I'm going to be making, and I'm going to do it quicker. She's going to take 25 days. I'll get it done for you. 24 days, and I only want a penny on the first day.
Yeah, but how's your work?
I'm good. I'm good. It's so good. I just hire her crew, and I tell them we're getting paid $6,500 a day, and I'm just going to run off with the money. So the question is, who's the better deal for Dawson? Me getting a penny a day, or her getting 6 grand a day? Keep in mind, mine doubles. So I want you to work through it. Obviously, on day 1, I'm going to get 1 cent. Less than $1. Keep in mind, Daisy got paid 6 grand that day. Okay, go. Work through it. How close do you think I'm going to get? She's 150 grand. I want you to write just on the top right of your page. How close to that do you think I'll be on my last day? Well, she gets 6 grand a day. What do you think I'm going to get on my last day? Will I have made it to 6 grand?
Well, you're like
Make a guess.
5 and you have 16. So,
Do I have 16 cents by day 5?
Yeah.
Man, look at me. We're going to have to figure out, we're starting out with 1 cent. And eventually we're going to figure out how much would I have to give myself to start with if I was going to catch up with her if 1 penny doesn't do it? How many pennies would I need on day 1? Anyway, go ahead and work it out. You said on day 5 it's 16 cents?
Yeah.
All right. I'm catching up.
Okay, 70. You got a dollar. $1.04.
Oh, here we go.
70.
I'm living large. I've almost made $1 by a week. That's incredible.
You know what? Feels funny. I think pilots are sitting on bricks on the house on the lunch thing.
I meant it.
I'm gonna go home and show my mom.
I meant it. That's what happens when you don't finish your homework. I just show up. You'll be walking home and
Just jumps out of
go like full Nancy Kerrigan on you. And it's quiet coming up on you too. It's,
Oh,
yeah.
that Nancy Kerrigan.
And like the weird.
Have you seen that footage? It's really awful.
And like a nice little bathroom voice. It's smashing her in pieces.
This is the homework you deserve. And then just, yeah.
Well, pulpy knees. Yeah.
What's this?
Pulpy.
No, I don't promise. I'm a pacifist. I don't believe in fighting.
So, she said the next day is four. Always says. Like the first day and the second day is 4. It says that.
Well, double it and then 4 pennies. I was kind of imagining this as a stream of consciousness. It starts to get more than you think, right?
Up to 30 bucks.
Am I at 30 bucks? What day do I get to 30 bucks?
Well, 30 for 28 cents. 12th day. Big up to
Are you adding them as you go? Are you making your life even more complicated?
double.
This doubling?
Am I doing it right?
I don't like this one.
Oh no, I think I messed up.
Yeah. That's okay. You can copy mine up to that.
Oh wait, I was doing it like time, like 60.
That's okay. I like it. I was not expecting that. That was good. That was a solid snort. Own it. That's what I'm talking about. Don't be embarrassed. Don't be embarrassed. Own it. That was can I say though, that's impressive that you could do that in your head.
What?
Like that, yes, it's wrong, but that you could do that as time in your head is actually pretty impressive to me. But don't.
Oh no.
What do we got here? I'm going to stop being able to do this in my head pretty soon. Oh, don't worry, we're just right next to it. Not. 163, 84 maybe? 327, 68 perhaps? Is that right? Okay. 655, 36. Is that right? Is that right? Okay. 13, 10, 72. 26, 21, 44. 88 cents. Okay, so on day 20, she's still getting paid more than I am, right? Day 20, I made $5,000. She made $6,000, and I made less than her every single day before. And yet, I think I'm going to beat her. And every year when I do it, I change her number and the days. So sometimes when I do this lesson, I beat her, and sometimes I don't quite make it. Because I like to be surprised too. So I just pick random numbers. Okay, can I do this? 10,000. $10,485.60.
Hold on, I'll do it.
76 cents.
Yep.
Okay.
76.
21. Nope. 29, 971 and 52. All right. 41. Okay, you gotta help me. I'm done. I'm out.
I'm done.
41943.
And how many cents?
04.
4 cents. All right, let's see if I can do this one. I can do this one. That'd be $83,886.08.
Wow.
All right. I like 4s a lot. 4s are good to deal with. 7s. Every time I get to a 7, I get messed up. I don't know what it is about the 7 times table. I know it, but I don't know it strongly enough to do it in my head well. Okay, so on my last day, I got paid 83 grand. And man, I'm going to add all these up. See if you can. I'm not doing that in my head. Actually, I will do it in my head. Add them all up. All right, add them all up. I'm going to try it in my head.
Add up all the numbers we got.
I think I can do it. How'd I do? See what you get.
Is it like the?
Now I got it. All right. All right.
I'm leaving. I'm going home.
Yeah, I mean it's almost lunch, so you're good.
There's a trick. I'll tell you after. And I probably still screwed it up. We'll see.
I hate like using a calculator on the phone.
The phone calculator, watch your language, please, but the phone calculators are not good, unfortunately.
And then you mess up and then you have to restart the entire. No. Literally. He doesn't use calculator. But the sharpener used to be way better.
Yeah, it's dulling. I don't know if you can take them apart and sharpen them.
Last time I sharpened them, they chopped off the tip of my finger.
Ooh.
Because my brother said something and I looked away as I was sharpening the blade, just chopped the tip of my finger.
Oh, I was off by a penny. I forgot. I was off by a penny. Oh, I'm so dumb. So you know what the trick is? It's actually a neat thing. And this is, you actually, the sum of them, this is true about any sequence like this where you keep doubling and adding up. When you add them all up, you actually get the next number minus a penny. Yeah, if you check. Like if you added all of these ones up to here, you'd get 41,943 and 3 cents. And if you added all of these up to here, all of them up to the 41,000, you'd get 83,886.07. It's always just the next number minus a penny. I forgot to minus the penny. Because of that 1 cent there. That's right. So it has to be odd numbered because you start with 1 cent, but every number after that is. So the total is $167,772.15, which, don't forget, I did in a mere 24 days. So what am I getting paid per day? Oh, divided by 24. So I am collecting almost $7,000 a day. $6,990.51 per day.
Okay, more.
That's right. I am more expensive. So this was my grand scheme. And let me tell you something. God help you if it rained one day and I got to day 25. Right? That'd cost you another 167 grand. So this process is what happens when we use exponents, which is to say when we multiply by the same number over and over and over again. What number did we keep multiplying by here? 2. We kept doubling. And so this is the effect of putting something, timesing it by 2, and then raising that 2 to an exponent. In this case, how many times did we multiply by 2? 24 times. So this would be 2 to the exponent 24. What we really did here, without realizing it, we could have done all this without any of the work. Because what we really did was we took 1 penny and we multiplied it by 2. How many times? 24 times. If you punch that into your calculator right now, it should give you this answer right here. Try it. Let's make sure I'm not screwed up, because sometimes I get screwed up. But you should be able to punch that into your calculator. 1 penny doubled 24 times, and you should get $83,886.08. Makes sense, right? Now this is a lot less work than that, right? A lot less work. This is what we call an exponential function. And the cool thing about exponential functions is that they are used to model things in the real world. This, by the way, is how investing your money works. Now the bad news is this. When you invest your money, does it double every day? No, that would be nice. I had a stock double once. I had one investment. I invested in a company called Rock Test, and this was a company that was a scientific company, and they built sensors that could test rocks. It was designed for like around California, where there's roads running under cliffs, and they could test the cliffs and put out seismic waves, and it would tell them whether there was a risk of crumbling rock or not, which is a pretty useful thing, right? So this could actually send out sound waves like sonar, basically, into the rock, and it could detect big cracks in the rock. And those big cracks in the rock can become rock slides that fall on people's cars and kills them. So this company had a pretty good deal going, where they would sell these to towns that had roads that went under big cliff sides, and they made great money. And then one day, there was a scientific article published. So I had bought stock in this because my stock advisor said, hey, this is a good stock, it's looking good. And so I had 5,000 in my portfolio that went to that. And then a report came out in a scientific paper that said this same technology could be used to test bridges to see whether they had damage. And all of a sudden, like, we don't have any cliffs that have roads near them. So the city of Welland wouldn't have bought one of those. But we have bridges. So all of a sudden, all these cities that before had no use for this technology, all of a sudden this is a really useful piece of technology. And the stock like more than doubled overnight. It was amazing. Like, I owned this stock, it had gained like $5 in the like 3 years I'd owned it. And all of a sudden one day it went from being worth $5,000 to worth $10,000. In 2 days. And then I sold it instantly. And it felt good. That's like my only stock success in my entire history of investing, but it feels like a good one. Felt way better than getting punched in the face, I'll tell you that. So there's that. Now, this can be used for lots of things. Anything that gets multiplied regularly. Have you guys taken biology or even grade 10 science? Yeah. Did you learn about how bacteria grow? How do bacteria grow? What do they do? Yeah, who remembers their mitosis? Prophase, metaphase, anaphase, telophase, cytokinesis. Anybody? Do you have to do like the flip book?
Exactly. Trust me.
This is broadcasting. Be polite. So
I'm sorry. Does he actually
I think it's pretty safe to say Trish does not listen to all of my broadcasts. You're probably good. Though maybe he does. Maybe he goes home at night and he's like, finally done with all those rotten kids so I can listen to Orlando for 7 hours, just like I always wanted. Because I assume he listened to some old ones too, like his favorites, like the greatest hits. He's like, oh, that lesson on exponents, that was so good. Listening to that one twice. And then tonight he's going to get home and hear that, and you will have ruined his day. Just so you know. You should probably buy him candy. Okay, so watch this. This is a real image of bacteria. Oh, this one kind of sucks. This is not the one I wanted.
Oh, my heart. It's just melting. I'm so proud.
Okay, you know what? I'm doing my best.
My heart's racing. I can't.
Okay, shut up. Okay, here we go. This one is good. This is sped up. So this is 540 times faster than real time. So basically it means that every second is 10 minutes. A little bit less, but roughly 1 second is 10 minutes. 2 bacteria become 4 bacteria. 4 bacteria become 8 bacteria. 8 are going to become 16. This is just like my pennies. By the way, this is why you can't leave your food for long. This is how they come up with expiry dates, because we know that a little bit of bacteria isn't dangerous. But just like in this example, the first bunch of days, 2 weeks in, I was still just making what, like 20 cents or something, right? Or like $1. I wasn't making a lot of money. It's like the bacteria on your food. At first, just a bit, 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 just a bit. All of a sudden, wham! All of a sudden, they go crazy because they're doubling and doubling and doubling. And that's why we can actually pretty accurately predict how long it will take food to spoil, because we know what kind of bacteria grow on different foods.
Not gonna lie, I've never seen that.
Have you not?
No.
I've only seen like 2.
So that is a legit bacterium.
Did it
Like,
say
that's
what
a real-
kind of thing was on
That
the
I
glass?
believe is Streptococcus, which is strep is a very common. Well, this is pneumoniae. So this is pneumonia. This is the bacteria that causes pneumonia in humans. So it's a dangerous bacterium. It kills lots of people every year. And you see how it grows, right? Slowly, 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 slowly. Whoa, out of control. Exponential. So let's talk about this, how we could actually model this. Let's imagine we start with a piece of chicken, and it's in your fridge, and it starts with 100 bacteria on it. And just to make our life easy, we're going to say they double every day. Truth is, it doesn't. For some bacteria, it takes longer than that, and for some, it takes a lot less. Different kinds of bacteria are different. So we're going to imagine this is a bacterium that's really convenient because every 24 hours, boom, doubles. That makes the math easy, right? So on day 0, when no time has passed, how many bacteria do we have? 100. That's our starting amount, right? By the way, that is, I don't know, in science, this comes up a lot, the idea of time 0. That just means when you start. No time has passed at time 0. In physics, time 0 is a big thing. It comes up a lot. It just means before anything new has happened. We define that time as 0. The land before time would be negative. Like the land in time saying -3 days. The Land Before Time is a great film, but I'm a big fan. All right, after a day, how many bacteria will I have? 200. After 2 days, how many bacteria will I have? Nice. After 3 days? And after 4 days? Very good. That's right. Okay, so let's first take a minute and let's just graph this. I want you to, I'm gonna do my best here. Put a scale on. And what I want is, in science, we almost always put time on the bottom axis. So if you're ever making a graph in science, whether it's physics, whether it's chemistry, biology, it's a pretty good rule that time goes down here, and we're measuring that in days. We're going to do a scatter plot. We're going to do a scatter plot. And over here, if time is down there, what goes up here? That's right.
Like 2 days ago?
Yeah.
Is Chloe Nishi in class? Yes.
She is, yes.
She put the guy to sleep.
Yes.
Thank you so much.
Wow, Claire, I will try not to have hurt feelings about that.
Oh no. I've been just waiting for this for a good week.
Literally. Please pack your bag.
I
Go your day home.
I'm scared.
What's your thing? It's like,
I heard you talking.
Can Caliper in, please report to Traction's room? I'm sorry. I didn't mean it.
I know Tom, sorry now.
She's not here. She's making a voodoo doll in fashion class to put pins in. Yeah, she said something about wanting it to wear like a Leafs jersey and a Pearl Jam hat, and awful.
Actually, do you still want this for you? We can use that for you.
Thank you. I will. Thanks a lot.
I wish I could. Don't get me wrong. I'd rather be in Orlando's class than any other class during the day.
Listen, if I could be at home in my pajamas reading a book right now, I would be. And I like my job.
What's your favorite book?
My favorite book, and you should all read it at some point in your life. I mean, I've lots, but 50 Shades. I'm more a 50 Shades Darker kind of guy. Anyway, I've never read any of those books. My favorite book is called Infinite Jest by a guy named David Foster Wallace. And I might be dating myself because this is like a very 90s book. He was kind of like the big young up-and-comer in the 90s. He was like the great American novelist. It's, okay, a little weird. It's about a physicist who is also a tennis player, who's also an experimental filmmaker, who makes a movie so entertaining that anyone who watches it literally amuses themselves to death, where they just kind of fall into a trance watching this movie and eventually like dehydrate and die. And so it takes place in a post-apocalyptic future after like some kind of nuclear war. And this physicist has recently committed suicide, but it centers around his family who run a tennis academy outside of Boston. And it focuses on a bunch of assassins from Quebec who ritually put their legs on train tracks. So they are double amputees. So they're the wheelchair assassins, and they are trying to steal a copy of this film so they can use it as a terrorist weapon, which all makes it sound pretty obscure, but it's brilliant. It's also anyway. So it's long, but it's worth it.
I read like half of it.
I liked it.
I just stopped.
Did you not make the? I thought it was a good read actually.
It's a weird part.
Well, that's the thing with Stephen King books is they all have these kind of weird moments where you go, what the hell? Uh-oh. I started at 1, but obviously where did I need to start? 0. Stupid me. Did you copy me? Yeah, so you should never... You know, did nobody ever tell you people not to trust anyone over 30? That was like a big thing that people said when I was like, never trust anyone over 30. And for God's sake, don't trust anyone under 30. Just don't trust anybody. Not just me. What am I? I'm not even a math teacher. I'm a science teacher who occasionally also teaches math, which doesn't excuse me for not knowing how to make a graph because we do that a lot. But people make mistakes. Don't copy me. I teach science this semester. I've got a chemistry, which is nice. Last semester I had a chemistry. So it's nice to mix up. I like teaching math, but I miss, you know what I miss is bio. I really like teaching bio. And I haven't taught it. The problem is everybody teaches bio. Every gym teacher. 1,000. Because I'm going up by what? I'm going up by, well, but figure it out. What am I going up by? What's my scale? 200. That's right. Okay, so let's plot these points. We're going to put them in one at a time. On day 0, what's the population? So I've got to go down to day 0 and up to 100, which is just halfway through here, right? All right, where's my next point? On day 1, I have to be at 200. Day 2, where am I? On day 2, I have to go up to anybody? I've put that on and that on. Very good. Up to 400. And by the way, right now, it looks pretty close to a straight line, right? Looks kind of linear. What's the next one? On day 3, I'm up to 800. And now the line is looking less good. Doesn't fit well. On day 4, all the way up to 1,600. And what we get is this very characteristic shape. This is called an exponential growth curve. An exponential growth curve. Would you like me to use the rainbow pen? All right. I like the rainbow pen. It is, and I was very excited about it.
Oh.
That's so much better.
Right? All right. So this is what we call an exponential growth curve. And there's a couple key points we should be able to find. I mean, they're super obvious, but this first point where it just starts off, is always the starting value. So things that grow exponentially follow this curve. They start off pretty flat, and they inevitably go faster and faster and faster. Time is your best friend with things that grow exponentially. This is why, if you've ever had somebody come, like they had that smart money guy come and talk last year, or funny money, what was that? Remember that assembly? He was like giving people $20 bills and stuff.
So they gave away $50 bills.
Yeah.
He was giving away money.
Yes.
Yeah, like $100 bill.
But he
Why
was,
was I not invited?
I don't, well, everyone was there. You probably skipped. Probably skipping.
Assembly.
But, because it was an assembly, and so you thought, I'm going to skip. Well, people got $50 bills. But, but no, really, but listen. The thing that, we're going to talk a lot about money in this course, because it's important. And the thing about money is this. Anyone who says money isn't important has a lot of it, right? Like you'll hear people say that money is not the most important thing, said some guy with like $1 million in the bank. Because I can tell you that when I was like first married and my monthly income was like $1,800 and my rent was $1,100, so like we had $700 for the month for everything else. Money becomes really important to you, right? Unfortunately, you're thinking about it all the time. When it's like, hey, it's the 22nd of the month and I've got $11 left. They're like, should we drive here? Nope, got to save gas. What are we eating tonight? I don't know, but I bet it's in a can. Like you think, yeah, black beans or white beans? Maybe we'll mix them together. So like when you don't have any, you think about money a lot. And it's only like I'm lucky now. My wife has a good job, I have a good job, we get paid well, and you don't have to think about money every day. Not enough I have to think about it, but it's in the bank, and I know that when the end of the month comes and I've got to pay my hydro bill, like I have some money to do that. Whereas like when I was 22, there were lots of times where like, okay, how do I find extra work to make, right? You'd literally be phoning up people who like have jobs at restaurants going like, do you have any events where you need extra people to wait tables? Like it's a miserable existence when you're scraping paycheck to paycheck, right? One of the things about money is invested money grows exponentially. And when it starts out, it grows really slow. So you can be tricked into thinking this is a bad use of my money, right? When you first invest it, like I remember we managed to save $10,000 by my 5th wedding anniversary. I had a $10,000 bank account and we took it and we invested it. And I felt like that was a lot of money. That wouldn't be a lot of money to a lot of people, but to us at the time, that was like tons of savings, right? And we took it and invested it. And like in the first year, I think that investment portfolio made like $82. And you're like, oh my God, like it just made nothing, right? But every year it grows a little bit and grows a little bit. I haven't touched that investment portfolio. Haven't touched it. And it is now 10 years later, and it's worth 70. A lot of money, just growing. Yeah, it just grows. It just does its own thing and it grows. I haven't put a dime into it. I have a different investment portfolio with the DSBN because we put money into our retirement. It's growing separately, but that one, it just grows over time because investments that start slow get big later on in the curve. The reason I mention this is the time to start saving isn't in the future when you have lots of money. It's now when you have a little bit of money. And like $15 a paycheck put away when you're 17 and 18 is more powerful than $200 a paycheck put away when you're 30. right? It's the earlier you get it in those. So if you can stress one thing when it comes to money, save early. Early. I was raised by an accountant as a grandfather and a math teacher as another grandfather. And they were Italian and Scottish, so they're all cheapskates. So saving was encouraged. But really, it is a good thing. Now, that's doing it as a graph. What did we actually do here? Because remember, just like with this, we said we started with a penny, we multiplied it by 2, and we did that over and over and over again, right? What did we do here? So this time, I'm going to call it like the population. What did it start out as? These bacteria. We started with 100, and what did we do? We doubled it. And then to some exponent, and I'm just going to put the word days up here, because you could use this to figure out any day, right? If it's been 13 days, how many times do we double it? 13. If it's been 52 days, how many times do we double it? 52. So here it says, what's the population after a week? Well, what would I have to do here to know a week? I'd start with 100. I'd double it. How many days is a week? 7. Do that on your calculator. See what we get. 2 to the exponent 7. I don't know that one off the top of my head. Might be 128. Might not. Let's see. Hey, it is. So how much is it? 1,280? Ooh. So if you start with 100 bacteria on your chicken, which is pretty safe, that's actually a really low count. After 7 days, there's only 1,280. That's actually a pretty safe count still. So a week in, your chicken's sitting in there, it's safe. You can eat it. Yeah, yes. Yeah, they grow a lot quicker out on the counter. They can grow in minutes out on the counter. We don't want to do that. Because it's not just their growth rate, it's also their ability to secrete toxins, which is a lot higher in warm temperatures. So yes, do not leave food out unattended. But in the fridge, yeah, a week in, we're still safe. Getting a little skeezy. What about 3 weeks? How would I do that now? I'd say the population, what did we start out with? 100. What are we doing to it every day? We're doubling it. But how many days is 3 weeks? Does anyone know? How many days is 3 weeks? What exponent am I going to have to put up here? 21 days. Cool. Plug that into your calculator to see what we get. I think it's going to be big. All right. I have a feeling that Mr. Pouliot would advise that you not use that piece of meat. Right?
Oh, no.
Okay, we're streaming again. Let's. Well, he'd just be like, just rinse it off. Oh, God. I don't want to think about that.
Please go to the wash.
Yeah, you bet. All right. So after I went, I had to do a safe food handling course once because I managed restaurants, right? And I used to work in the kitchen. So I was up for recertification. So I had to go back to the school for safe food handling. And you guys get to do it right here in school. But if you work in a restaurant, they have to ship you off. So we went. And so it was me and a bunch of line cooks. And line cooks, like just guys who work on the line. And this one guy kept asking questions. They kept saying, like, at my friend's restaurant, and then asking these really awful questions. He's like, well, at my friend's restaurant, the chef says that, like, spices kill bacteria. Is that true? And the teacher was like, no. And he's like, well, at my friend's restaurant. I'm like, I don't think you're talking about your friend's restaurant. I think you're talking about your restaurant. And then he wouldn't tell us where he worked, and it freaked me out. I always think about that when I go into a new restaurant. I'm like, this guy thought spices kill bacteria. And if I ever saw him back, though, I would just turn away and run, man. I wouldn't eat a thing. I wouldn't even trust a salad. At my friend's restaurant, they Yeah.
Can you Samantha start, please?
Yeah, absolutely. Now, that's if we multiply by the same number over and over again, right? But the other thing we can do is we can make something smaller. We can not multiply over and over. We can divide over and over. That's not called exponential growth. That's called exponential decay. That's right. How did you know? How did you know?
I don't know.
You are so clever. You know, I don't even know how you knew that was the word I was looking for, but there it is. Look at that. It turns out it's on the page. So exponential decay is when instead of something getting bigger, it gets smaller. And you guys are going to do this one, all right, rather than me draw it out. But this is how balls bouncing work. And it's not always exactly half, but it depends on the type of ball, the type of surface, how inflated it is, right? You all know this, that if you underinflate a basketball, it won't bounce very high. But actually, if you overinflate it, it doesn't get as much bounce either, right? Like there's that perfect.
I was going to say, I feel like over, you can let it drop and the thing just kind of goes there. So how they really.
Yeah, at a certain point, it kind of just thuds. I mean, not perfectly just thuds, but at a certain point, if you put too much pressure in, you kind of lose a bit of bounce. Anyway, that might not be true for basketballs. I don't know. That's definitely true for volleyballs, where if you overinflate a volleyball, you actually start losing bounce, to say nothing of the fact that they really hurt. Yeah, when they're overinflated and you go to like jump serve, it's like that really hurt.
Grade 8 gym class.
So for a nice simple example, a ball is bounced from 40 feet, and each time it loses half of its height. Fill out the table and then make a graph. I think you can. Just like last time. All right, so go ahead and fill that out. Yeah. Yep, absolutely.
Hey, Melinda.
Yes.
So if at 40, if you take in
So a day later, what's it going to be?
20,
Good. A day after that?
that's going to be 0.
No, half.
Oh,
So
10.
and then 10, and the day after that?
2.5.
You got it.
Okay.
Bingo.
Thanks.
Even by your own standards, you've been very tired.
Okay, I don't want to make this graph.
I do.
Oh.
I'm drawing. Oh, makes me feel comfortable.
I'm not creative.
Go ahead. And then drop
Is it gravel? No. You got gravel.
I have an electric blanket. I'm worried that's going to set my house on fire, but until it does, it's like my favorite thing.
I know, I would go like Adams or whatever.
I do, that's a good concern, because they're straight up dangerous.
Thank you. My head hurts. My tongue smells.
It's intense right now. You're at that age.
Will Paul ever stop bouncing? Yes.
I refuse to do it.
No, you don't.
I don't want to.
Yeah, but you're going to do it.
But I'm not
And I appreciate it.
I know you.
And which thing do we put on the bottom again? Always?
I would say, don't you feel like the time?
Time on the bottom. So in this case, time is like number of
If
bounces.
you
How many times?
give me the scale and all that, I'll do it.
Okay, deal. That's fair.
I'll do my own plots. But
So let's work on the scale. So bounces, we start at no bounces, so 0, and we'll just go up by ones, yeah? 1, 2, 3, 4. And if we wanted to, we could keep going. And then what's the maximum height we need? 40. So we'll go 1, 2, 3, 4, 5, 6, 7, 8. So maybe if I go by 5s, that'll get me to 40. Nice. Yeah, I like that. All right, get your points on that. like neglecting you way back in the back. Look at you.
Okay.
But you see, I needn't have worried because you're way ahead of the curve. Let's get our points on here, shall we? Yeah, let's do it. All right, where's the first one go?
Okay. Oh, here?
Yeah.
Wait. Is it 0? Does it go?
Yep. Fantastic. I like it. I'm going to copy.
Wow. This is great.
Nice.
I don't know. Half of this?
Yeah.
Okay, we're gonna wash him.
Of course. And the cool thing about graphing them actually is the next point is always easy to put on because it's just half as high, right? So even without the table, I could be like, oh, half again, oh, halfway. It's like in football when they commit a penalty closer than 10 yards to the end zone, you just get sent halfway to the end zone. Yeah.
Excuse interruption.
Yeah.
Will we report to the office at the end of the period, please?
She's already on her way, actually.
Okay, thank you.
I feel like I'm very popular. Now, if we were going to draw a curve through this, what would it look like? Lamontagne, draw a curve through yours. Oh, did you already? What a guy. Look at that. I never seem to get very nice curves, but I'm going to do my best.
I don't know what song this is, but
And this is what we call not an exponential growth curve, but this one is called an exponential decay curve. This is where things exponentially get smaller. So again, you drop that basketball, the first bounce, then the next. Each additional bounce gets lower and lower and lower, right? Okay.
I was doing nothing.
Exactly. So, I know, and draw your curve through it. And this is the starting value here. The starting value is the highest point on this one, and that's going to decay from there. It's going to go down. Tomorrow we'll look at a bunch of examples of these. You might even have time to get one done on your own time today. I don't know. But can we make an equation from this? Well, just like last time, we can say the height is just going to be, well, what's it start at? It starts at 40. And then every time, instead of multiplying by 2, we are this time dividing by 2, right? So what could I put in here? If I put 2, that would mean multiplying by 2. But I could put a half, right? And that's dividing by 2. And then now, we would just do that to the exponent of however many bounces it is. That make sense? Now, according to this graph, should the ball ever actually stop bouncing? It'll just get smaller and smaller and smaller and smaller bounces, right? But according to this equation, the ball would keep bouncing forever, just really, really small bounces. Now, in actual physics, that's not how it works because there's friction with the ground, right? And eventually it would just stop in place. But according to this, so really quickly, let's say on the 9th bounce, what should its height be? Tell me that. On bounce 9, tell me its height. So again, it's going to be small, yeah. Going to be small. How would I do it? Well, what did we say? How's the equation work? We take 40 and we keep dividing it by, well, we keep multiplying it by a half, right? How many times am I going to do that here?
So you do the little weird.
So 40, that's right. 40 times a half. How many times do we cut it in half? 9 times. And then you can just plug that right into your calculator. And the nice thing, these calculators, you can actually do it exactly like that. 40, open a bracket, a half, close the bracket, press the exponent button, 9. You're done. And that's what I get. So by the 9th bounce, this thing basically isn't bouncing. Was this meters or feet? Was it feet? So we're talking about less than 1/10 of 1 foot, right? So less than an inch. Not a lot of bounce. There we go. So tomorrow we'll pick up with that. I think it starts with people spreading rumors about me. It says Jade, but who's going to spread rumors about me in here? I think I know.
So you don't actually write your own.
Sorry?
You don't actually write your own.
No, it does. I told you that I made a new version for you guys with all your names, but I accidentally grabbed mine from last semester when I taught Jade and Evan. I actually make all of my own notes, which is a point of pride for me, except for when they contain obnoxious spelling mistakes or numbers that don't make sense, or I use the same letter twice in one triangle. And actually, this course has been nice because I'm making half of them and Cleves is making half of them.
Orlando, what was the equation?
The equation ends up being just this, and it makes sense. What it means is we start at 40 and we cut it in half. And how many times do we cut it in half?
I was close.
What did you do?
I did 40 divided by 2, and then like 8.
Yeah. That's totally right. Totally right.
Yeah, I know what
Yeah.
I took like the old. Like,
Yeah.
probably, like,
And the only thing is to say that we divide over and over again.
We have a great lunch for you today. We have a cabbage roll soup. We have Greek salad.
We have
We have pizza stuffed with onion rings.
Yeah.
We also have stuffed chicken with Alfredo sauce, mashed potatoes, and mixed vegetables.
and then
And then we
I
have
just
the
asked you
assorted
guys on the
sandwiches as usual, mac and cheese, cookies, chips, and drinks. Come to the caf for an amazing lunch and amazing dessert.
40 times, and do it like this. 40, open a bracket.
One piece of lettuce left. But you bet you money.
Yeah, and then just 1 over 2. And that means divide by 2. It's just the way the calculator works. And then just the exponent for how many times. In this case, I said 9.
I was getting ready for this.
In this case, 9. On the 9th bounce.
Orlando, have you had car trouble lately?
No.
No?
No, but CAA, man, I was taking my kids to camp this
I got a
summer,
membership for free.
and I had changed my own brakes on my Equinox,
Okay.
and I obviously had not.
Too?
Yeah, I like my Equinox actually,
Oh, they're
but
great.
I obviously had not sufficiently lubricated the calipers,
Yeah.
well, the piston in the calipers, because it seized. And so at highway speeds, all of a sudden I was getting a good smoke off it. And so I was like, no problem, whatever. I just need some caliper grease. It was a Sunday at 2 in the afternoon. And I was in friggin' the middle of nowhere, Ontario.
There's a story
And
about everything.
everything was closed.
Yeah.
Everything was closed.
Call it the
Couldn't go to
CAA.
Canadian Tire, couldn't go to any mechanics. So I had to phone CAA and I said, like, honestly, I've got a jack, I've got my toolkit. All I need is caliper grease, like brake grease. And they said, we'll be right there. And sure enough, about 20 minutes later, the truck pulls up. He hands me a tube of caliper grease, says, do you want me to do it? I said, no, I'm good. And I jacked it up and did it, and all good.
Pretty good.
They're great. They're amazing. See ya.
Since I did like, I got a free year of CAA.
Oh, nice. Did they give you a free year of CAA?
Yeah.
That's a